always situations that you have to be aware of. In particular, going to spend a lot of time with boundary conditions. So we're not going to get general solutions with a plus C. We're going to get instead particular solutions where that plus C is going wonky. When we were doing yesterday, the plus C's, one of my students has told me that sometimes the WebAssign will do a minus C or a plus 2C. They'll actually do the calculation to it, so it won't be C anymore. Have any of you noticed that, or did it work fine if you just did plus C's?
I think I noticed that in one of the problems.
That it wouldn't take a plus C, it had to be called minus C or something?
Yeah.
Yeah, so if you know you've done it right and it's not matching it, well, I refuse to do it myself because I just don't want to break that rule. But to keep WebAssign happy, you might want to choose to do that. And if you really have a trouble with it, then shoot me an email and I'll just give you the point for the homework and that'll cover it. Okay, let's start with, I hope, a relatively straightforward one. Here's a differential equation, which is going to be variable separable eventually, but we've got to do some algebra to make it happen. So it seems reasonable that what you should do is divide both sides by x squared plus 1. And if you're not careful, you'll think, hey, I'm good to go. Right, we'll do the crossover. But have you noticed everybody's in the wrong place? Shouldn't it be x's on the top and it should be y's on the bottom? So what I'm going to do now, hopefully with some help from you, is fix it. And we've seen this a lot of times. See if you've got something like y cubed, x squared, whatever it is, and it's in the top, but you want to move it down, say, to the other position in the bottom. Don't you just call it -3? And I've got x squared plus 1 on the top. Well, I guess I could call it x squared plus 1 is -1, but that's probably not a very helpful way to write it because you're going to integrate it in a minute. So I would suggest we did this one again. Right, so have you seen that little trick before? So now we can do the crossover. So y to -3 dy add 1 to the power, divide by the new power, inverse tan. Right, we're all happy about the antiderivatives, power rule on the left. Just we have a good memory for the second one. We just know what that is. Can this question be written as y equals? So we got to make it y equals. So multiply both sides by -2. And we'll do that thing, you know, plus c still plus c. If you multiply it by -2, we'll use that. This fella is probably better written as a 1 over y squared. And we've done this before. 1 over y squared is this, so what's y squared going to be?
One over -10.
All that stuff. Great. The 1 over part. And that makes y, technically, plus or minus the square root of one ugly looking fraction. And that guy is called the general solution to this differential equation. And it's a general solution because it has a plus c in it. I'm going to just mute some people for background sounds. And go back in. Well, in a lot of questions, that would have been the finish. But we have a boundary condition, sometimes called an initial condition. And that guy's job is quite straightforward. Isn't that guy's job to tell us what number plus c is? And it's probably also going to tell us whether it's the plus square root or the negative square root that we're going to use. Great. And I can tell you right now that it's going to be the positive without even doing a calculation. And the reason is, isn't y at 0 a positive number? I mean, you agree cube root pi is a positive something, right? Well, you plug that in here, don't you have to use the positive square root to get a positive number? So I know it's going to be positive just because of that. So I'm going to put x in here is 0, y is that guy. So y is going to be, because we've already argued about it, negative 2 tan inverse tan of x plus c. And on this side, we have the cube root of pi. And on this side, we have 1 over, well, the inverse tan of 0 is still 0. So basically, you just get that. Are we good? Right now, what is the quest here? Well, isn't the quest to find c? It's going to be some ugly number, and we need to find it, right? Think of solving equations. As long as you do it to both sides, it's okay roll. What should I do to both sides here?
Square it.
Square it. So cube root of pi. Well, if you square it, isn't it? Basically, you can stick it inside the cube root if you want. And now I'm going to do a trick that we've done before. If 1 over c is equal to something, isn't c equal to the 1 over the something? So how about 1 over cube root pi squared? So our particular solution is a positive square root of 1 over negative inverse tan of x plus 1 over that guy. Not the prettiest answer in the world, but that was because I created the question and not the textbook. Any questions about that particular one? None good? Okay. Let's choose something from the homework now. Okay, this one's going to be a general solution because there isn't any boundary conditions given. I already have a derivative, so that's good. What I don't have is a fraction. I want the x's on the top. I guess the next stage is that square root of y thing, right? Yeah, I got to write it in a form that's going to be easier to integrate as well, and I don't think the square root's a good place, right? So if you think of the square root of y as y to the half, that would be a good start. So what's it going to be now? Yep.
Y to the negative 1.
Right. So we're doing that negative power thing, right? Top to bottom. Works the same way. If you've got some in the bottom, you want to move it in the top, negative power can do that. Now this is ready to go for the crossover. You agree? There's nothing particularly weird about that one. Okay, power rule. If you add 1 to the power, and dividing by a half gets you 2, and you add 1 to the power, and you have your plus c. And since there's only y here, this is yet another example of a question where you will be able to get a y equals version. I'm going to call that the square root of y, and divide both sides by 2. There's just one thing to do now. We're finished. So what do I do to both sides?
Square them.
Square them. And do you notice that it's the whole package being squared? It's not this squared plus c squared or any other thing. It's the whole thing being squared. And that is the general solution to this differential equation. So that one didn't really involve that much at all. Okay, let's try an awkward one then. Let's try something like question 11. And it's going to be 4, the square root of pt. And it's going to have a boundary condition that p of 1 is 8. So when I look at this question, I think the first thing that strikes me is this square root of pt. It can't stay that way, because if it does, I'm really in trouble, right? There's nothing I can do. So I'm going to take it a little bit slowly, and I'm going to say that you're allowed to do that. Would you agree? And then I'm going to say, okay. And again, you might not need each of these lines, but I'm going to do them. That I know, because later on I'm going to integrate, and I might as well do it right now anyway. Shouldn't I turn square roots into fractional powers? And then I can kind of finish the question off by figuring out how to make it a fraction. And the t's have to be in the top, right? And the p's have to be in the bottom. So I keep the number in the t's, and this guy comes downstairs. Does that make sense, Martha? What I did there, does it make sense? Does it follow a kind of logic that we've been doing in other situations? Right. Break it into bits. Figure out how to make it a fraction with everything in the right place. And once you get to there, it's a little bit more process now. It's pretty much follow the instructions. The crossover then. Right, if you add 1 to this power, you get p to the half, and then divide by the new power gets you 2. If you add 1 to this power, you get 3 halves. Dividing by 3 halves is like multiplying by 2/3. So that's where the 8/3 came from, plus c. Now this one will be able to be written as a p equals, right? Eventually. So I'm going to do that. I'm going to divide everybody by 2, so that now becomes 4/3, and keep that guy as a C. What do I do to get P then? What do I do to both
Square
sides? And big brackets around it. And that's our general solution to this differential equation. But that's not what they wanted. And I know that's not what they wanted because they gave me a boundary condition. So basically, I'm going to find out who C is now. So I'll start with our guy. And we are really being told that when T is 1, P is 8. So this guy is going to be 8. And it's going to happen when T is 1. Well, 1 to 3/5. It's just basically 4/3. Now our job is to solve for C, right? So it's solving the equation, essentially. We have to try and make sure that the answer to C, even though it's going to be downright ugly, that it has to be an exact value. So I'm not going to find out what the square root of 8 is as decimal or anything like that, because that wouldn't be an exact value, right? That'd be a rounded off decimal estimate. So would you agree the first thing I need to do is the square root of both sides? So I'm going to have the square root of 8 is 4/3 plus C. And then I'm going to subtract 4/3 from both sides to get C. And then I'm just going to pause for a second and say to myself, is there a better way of writing this answer? Is there something I could maybe do to make it a little bit prettier?
Could you write square root of 8 is 2 times the square root of 2?
Yep. And that is going to be C, which means we now have 4/3, that guy, plus C, all squared. And that's the particular solution to this differential equation. Everything okay? No questions? Okay, that worked. We haven't got too many to do today, so let's see who we got left. Ooh, that's a good one. Make that the last one, I think. This is like question 9. And it says, find the equation of the curve that passes through the point 0, 2, and whose slope at any given random point xy is x over y. This may not look like it, but this is a variable separable differential equation. So somehow in all of this, we have to figure out what the differential equation is. And the key I'm going to use is the slope at the point xy is this. Isn't the slope to a curve the derivative? And in this case, it's a simple x over y. Are you comfortable about how I interpreted this last piece and created my differential equation? Now, what about passing through the point 0, 2? Well, that's actually a boundary condition. And what that is saying is y of 0 equals 2. When x is 0, y is 2. Do you see that's a boundary condition? So there's probably an infinite number of curves who have the property that their derivative at any given point is x over y. But for all of those curves, there's probably only going to be one curve that passes through that single point. That's why we're going to get one particular solution out of this. Now, actually, the setup is the hardest part in this question. Right, the setup is pretty much it. Because when I look at this question, is it variable separable? Yep. Is it everybody in the right place? So we go straight in the crossover. And you can't get much easier than integrating an x and a y. So this guy is 1/2 y squared, and this guy is 1/2 x squared plus c. So far, so good. Would you agree this is a candidate for being rewritten as y equals? So multiply everybody by 2. And get y. Right, and remember, square roots generate pluses and minuses. So right now, that's our general solution, right? If you tell me this piece of information here, is it going to be a positive square root or a negative square root? Just using the fact that we know this.
Positive.
Right. If that had said y of 0 equals -2, in other words, it passed through the point 0, -2, right? If it had said that, wouldn't we have chosen the negative square root as our answer? So if you take this fella here and use it in here, we have the positive, that guy, and we plug x equals 0 and y equals 2. I just read that the wrong way around. There we go. Oh, God. 2 things at once. Go. 2 square root is 0 squared plus c. Got it right. Finally done it in the right order. That makes 2 is the square root of c, and that makes c is 4, which means we now have a positive square root of x squared plus 4. And that is a particular solution to our differential equation. Right? Now I'm going to give you a challenge. Exact same story. Exact same story, except the derivative at the point xy isn't x over y, it's y over x. And it's going to pass through the point 1, 1. Okay, you got 5 minutes. Solve that one. So it would be a curve that passes through the point 1, 1, and whose slope at any given point xy is y over x. Now, all I've done is switch the two guys round. And trust me, that is not a pretty thing. Guess I should keep that there, maybe, for a little while. For those who need a little start, that's the start. No pressure, but I'm giving you 30 seconds. Okay, you can catch up if you haven't finished it already. This guy is deceptively ugly. It looks so much ready to go, but it isn't. In fact, isn't everybody in the wrong place? Right? The Y's are on the top and they shouldn't be. They should be in the bottom. And the X's are on the bottom and they should be in the top. And I could call them Y in -1 and X -1. So if you did, that's fine, but I'm going to change it in a moment. Wouldn't be that the way to take care of that. But I know I'm going to integrate these two guys, and it's really important that you realize that 1 over X and 1 over Y is a much better form. Normally you would leave it as X to -2, Y to -4, and that's fine because that makes sense. But in the special case of X to the -1, you really need to write it as 1 over X. Now, when we do the crossover, which we can now do, we get that. Now, this fella is the natural log of Y, and this fella is the natural log of X plus C. And there's our general solution. That wasn't too time consuming. And now you're going to plug in 1, 1. Well, the natural log of 1 is equal to the natural log of 1 plus C. 0 equals 0 plus C. C is 0. So that makes this fella the natural log of Y equals the natural log of X plus 0. And you might say, why didn't you turn that into Y equals? Well, the reason for that is because I'm going to do it right now. So how do you take the natural log of Y equals the natural log of X, and how do you get this guy to be Y?
Put them as powers of E.
Okay. Wait a minute. Isn't that guy just X? It's kind of elegant, that answer, isn't it? It's such a simple answer, which may have got you to make life really difficult when you didn't need to. Okay. We have one last question to do. Kind of kept the best till the end. We're going to do one of those differential equations where there are unknown constants floating around, you know, like the A's and the B's and things. So this one is similar to question 12. dl by dt, so the rate of change of length with time, is directly proportional to the square of the length and of the natural log of t, and you're being told that boundary condition. Well, I do not have a fraction yet, but I would like one. So t's belong on the top, and l's belong on the bottom. We're comfortable with that. It seems like a trivial question, but it might not be for some of you. Is this equation going to be an L equals when it's finished or a T equals when it's finished?
L equals.
Right, that's correct. How do you know? Because when it's not X and Y, sometimes it's hard to figure out who's the X and who's the Y, you know, who's who. How do you know? Because that was correct. How do you know it's L?
dy is always on top, and so it always goes first, and then so that means that dl is the same thing as dy.
Yep. Perfect way of saying it. couldn't say that better myself. So crossover time. Add 1 to the power, divide by the new power. Okay, that k is just an unknown constant. Just means whatever I'm going to write here is going to get multiplied by k, right? So the natural log of t has an integral. I'm sure we did this guy yesterday. Not this question, but this guy. What is the integral of the natural log of t? If you don't know it by heart, you do. Integration by parts.
Is it secant of t, tangent of t?
No,
I can't remember.
that was a good attempt. At least you tried. Last chance. T ln of t. Take away t. That might mean that in your working at the side, you'd need to figure out that. And to do that, shouldn't you call it 1 times the natural log of t? And that is going to be f, and this is going to be g. And we are going to do integration by parts. So that's going to be f capital G, take away the integral of f dashed capital G dt. And log of t, integral of 1 gets you t, so that's that piece. F dash gets you 1 over t, integral of 1 gets you t. So you have t log t minus the integral of 1. And that's where the t log t take away t comes from. So that's how you do it if you don't memorize it. So far, so good. I think we're going to have problems with this next guy. You don't need this line, but I'm putting it in right now. I'm just getting rid of the k thing. It's not really a common factor because it only belongs to 2 of the things. It doesn't belong to all 3. Now I'm ready for making this L. So do you want to divide both sides by -1 this time? Okay, or multiply if you feel that way. Oh, I've heard another way of doing it. Change the sign of everybody. It's essentially the same process. So this becomes negative. This becomes positive. And C doesn't obey those rules. Now this fella looks like that. And I think we've seen, is this about the 3rd time today this has happened? We got a 1 over somebody and we want to make it an L. And that's 1 over . And that's the general solution to the differential equation. So far, so good. Right, we're almost done. We only have 1 job to do here. Use this to find out what number C is. Well, I'll rewrite the thing again over here. And this is just to prove that you don't always get pretty answers, right? Even the textbook gives you some ugly looking functions. And if you tell me I'm this fella, you're telling me when t is 1, L is -1. So this is going to be -1. And it's going to be negative k times 1 times the natural log of 1 plus k times 1 plus c. And we are eventually going to find out what c is. But sometimes it's a good idea just to take small steps rather than try and do too much in one go. Would you agree that the natural log of 1 is 0, so that whole chunk there is just nothing? Right, natural log of 1. And k times 1 is just k, so what we've really got is that guy. So far, so good. Now, when you solve for c, you do not do that weird algebra where c just ends up being plus c all the time. Now c has got to, if it gets doubled, it becomes 2c, right? If it gets multiplied by -1, it becomes -1c. We've got to keep that in track. How are we going to solve this? What would be a good algebra trick to do next? I can do two different things, both end up being essentially the same destination.
Can you switch the numerator and the denominator?
Okay, so that becomes k plus c over 1. Wouldn't that just still be -1? Because -1 over 1 and 1 over -1 is -1. In fact, k plus c over 1 is just k plus c, isn't it? And to get c then, what do we do next? And don't overthink it, it's pretty straightforward. What do you do to get from there to there?
Take away k from both sides.
Negative k minus 1.
Okay. Which means L is 1 over negative kt natural log of t plus kt. Technically add, but add those two guys, get you that. And stick a fork in it, it's done. So that is us for today. Will you say hi for attendance? And I'll hang about a little bit at the end. Any questions, so on, we can deal with that. If you're good to go, bye-bye. I'll see you tomorrow. If you have any questions, I'll hang about and answer them. Have you got a question? Nope. We are out of here then. Oh, wait a minute. Matthew, do you have a question? Last chance, Matthew. I'm leaving. And we are out of here.